please welcome Professor Przemysław from Warsaw School of Economics. He is also adjunct professor at Toronto Metropolitan University, right?
Yep.
And he will tell us how to use Julia to deal with data with OpenStreetMap.
Okay, thank you very much for this introduction. So I'm going to talk how to use Julia for special data processing, and I'm working on quite a few libraries to cut things short. So I'm working with OpenStreetMap data, which is a kind of hierarchical XML data representing all world around us. It's built like of Wikipedia by thousands of volunteers around the world, and there is lots of information there. And what I'm interested particularly, I see this data as graphs, and I'm also interested in the metadata that is present there. Okay, so I'm working on the following three libraries. At different speeds. Sometimes I'm focusing one on the other. One was abandoned project OpenStreetMap that I named OpenStreetMapX and revived it some years ago. Then I made some simple library for plotting. And then recently I'm writing a set of scrapers because it seems there is plenty of data in OSM formats. And if you want to extract some special data like from Google, if you want to find one restaurant, it's easy. But if you want to find 10,000 restaurants and you want to scrape, you get blocked by Google. And even if you pay money for extracting information about restaurants, businesses, places, etc., then they throttle it because they are very afraid of the competition and they just don't want to scrape all their special data. But this data is available in OpenStreetMap. So what I'm going to show is how to scrape it. So I have only 10 minutes, so I took the most crazy and risky approach. I have Jupyter Notebook that has no resolved cells. So let's see if it's going to work. Okay, so how does it work? So the data, so I have prepared some OSM file containing information about the area around the haven, and suppose I want to plan. For tonight, I want to visit all pubs in Eidenhaven. Okay, I want to visit each pub and I want to find the location. So this is the query. So this is some query. So this query is related to how XML data is structured, but basically there are key values, and pubs can be described as pub, as bar. And also I want to start here from the stadium just after the classes end, so I want to scrape also the data about the stadium. Okay, so this is the query, and then I run the query on the data. Now, this query mechanism is pretty kind of fast. It can do like 2 gigabytes per minute, which is, and if you take a map of entire country, like a map of Holland, then it probably would take like a few minutes to scrape the entire map and have, for example, all pubs in Holland. But I just focus in the neighborhood area. So as you can see, I'm getting latitudes and longitudes of all pubs. Okay, I will be starting from the stadium. So this is the location of the Philips Stadium. So here we are at this building. Now, I might also want to have additional metadata. So there is an additional parameter, all tags, that is extracting also additional pieces of information, like we have name of the pub, opening hours, and so on. This is going to be shown. I want to visualize it, so I'm changing this data to a dictionary. Okay, so this piece of code is changing it to dictionary, and now I'm going to recode the coordinates, because I want to make a plot of this map. So I'm using another library, OpenStreetMapX, to recode the coordinates, to read that map data. Now, what I do, I will calculate distances for each pair of pubs. Oh, one thing I didn't say, I think I filtered this data somewhere, that I'm just taking restaurants which are not further than 1.5 kilometers from the place. Oh, I do it here. I'm filtering this data to take the restaurants which are not further than 1.5 kilometers away using like city metric. Okay, so I'm also calculating a simple distance metrics. I could use actual roads for this, but just for simplicity, I wanted to calculate it fast. So I have now 40 pubs, and this 40 includes also the Philips Stadium, so this is the set of distances. So there is nice Julia library to find the travel path, and then I can I can load a Python library from Julia, which is named Volume and which is very nice, and I can visualize what I've scraped. Oh, and I lost the internet connection, and I'm not seeing the underlying map. Okay, so let me check if I can quickly connect again. So sometimes it disconnects. So there should be a map underneath. Blah, 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 blah. Yeah, so this is a live demo, as you can see, but maybe I can resolve it. I need to be fast. I have 4 minutes left. Okay. Because otherwise, we do not know how to work. Okay, so this is the plan. So here we start at the Philips Stadium, and these are all pubs within 1,500 meters. And then you can see these are all the data that we have just extracted using Julia for the OSM file. So you can see the amount of meta information is quite big. And basically any business information or any type information you can very quickly extract in this way. And I'm thinking it is about a tool for building large data sets for various types of analysis, because if I can scrape the data from maps, then we can do many types of analysis. So I'm doing agent-based simulations on cities. So my future goal is maybe to create a code for generating of synthetic cities. Like in graph analysis, we have generation of graph analysis. In agent-based simulations, we have synthetic populations. And here I might want to generate synthetic cities. OK, so we have the map. And then another thing I could do, I could go slightly broader. So here I'm scraping from this data information about restaurants, fast food courts, bars, cafes, etc. And if I have this information, another thing I'm doing, I'm trying to aggregate this data. So I could make a plot that is describing the attractiveness of that area. This is also supported by this library, some measures for attractiveness of a particular location. So there's lots of research in the area of walkability city and how it's easy and how it's comfortable to go around the city. So this attractiveness of the area, Eidhaven, is here measured by the availability of pubs, restaurants, ice cream, cafes, and so on. And so in Eidhaven, it's easy; everything is here. Okay, so this is how this library can be. This is how this library can be used for. This is how this library can be used for spatial data modeling. So you can see we start with defining what we want to scrape, and basically these are key value pairs. This is how just the data is being aligned, and then in this way, very quickly we can build huge data sets. And the goal of this library is to be able to process entire big areas, like taking the data, for example, entire country and scrape out the addresses of all businesses and so on. So far before this library, my feeling is that mostly everybody was selling this data. So I had an idea to write a simple library to make this data for free. Okay, and thank you very much.
Any questions?
Excellent talk. I joined a little bit late, unfortunately. So I'm not sure if you mentioned earlier, do you have any parallelism to help you compute this in OSMToolset? And if not, do you have any plans for this?
Okay, so we have plans for parallelism. So one thing we are, thank you very much for the question. So the question was about the parallelism. So there is also additional functionality for tiling of maps. So basically, if you have, we have a map, and if it's a raw data like XML, a map is a 3-layered data structure. So the problem with the parallelism is the following: that in the map we have those three types of elements. There are nodes, which are kind of points. There are ways, which are sets of points, and there are relations. So it's a like 3-layer data structure. And this library already is providing already quite fast tiler mechanism that you can take this XML of map data and then you can slice it into pieces. And it's sometimes not trivial, because how to slice the stadium in half or so on. So it's using some heuristics to decide which goes where. So there are plans for this, and it's something under work. Thank you.
All right, any other question? If not, let's thank the speaker again.
Okay, thank you.